Hi everyone, it's my great honor to present our work here. The title is Develop AI Teaching and Learning Resources for Compulsory Education in China. We are from Beijing Normal University. In China, AI curriculum is embedded in the Information Science and Technology curriculum. In 2022, the Ministry of Education of China releases new Information Science and Technology curriculum standards, which means the course will be required to take for compulsory education students from grade 1 to 9. In other words, more than 158 million students in 207,000 primary and junior high schools are supposed to take at least one class hour of information science and technology, including AI, per week since 2022. However, in China, not all teachers and schools are fully prepared for teaching AI. Since AI used to be an elective course, most in-service teachers do not have solid ground of AI-related content, technological and pedagogical knowledge. This is partially because of inadequate teaching and learning resources, which requires a major expenditure of time and effort to design and develop. Even if teachers are willing to develop AI courses and the resources from scratch, most of them do not have enough time or sufficient capability. Relative to this, most schools do not equip with dedicated software, hardware, or classroom for now. So based on that, we proposed our AI knowledge structure and resources, which contains 90 core concepts, 63 learning indicators, and 27 teaching and learning resources. We cooperated with Tencent, the largest AI company in China, to develop and release the AI knowledge structure and resources. Teachers can also redesign lessons based on our instructional design so that they can save time and incorporate expertise from other researchers. Let's first talk about our AI knowledge structure. In the middle column is ours. Our AI knowledge structure is generated from the Chinese national curriculum, showing the left. Also, our knowledge structure is compatible with the 5 big ideas of AI for K-12, showing the right. Going to the details about our AI knowledge structure, including 3 main parts. They are core concepts, learning indicators, and the teaching and learning resources. Our core concepts are highly AI-related concepts selected from the Information Science and Technology curriculum. Learning indicators are learning objectives for each core concepts, which indicate what students should know or what students should be able to do. Then we designed dedicated learning and teaching and learning resources, which I will introduce in detail in the next part. There are 6 modules in our knowledge structure originated from the Chinese national curriculum, including first, introduction to smart device, second, data and coding, third, basic algorithm, and the fourth is process and control, fifth is foundation and realization of AI, and the last one is application and ethics of AI. After building the core concept and indicators, we elaborately developed AI teaching and learning resources as courses based on project-based learning. Students are inspired to practice self-inquiry through project-based learning and explore answers in multiple fields of studies. According to the national curriculum, our AI courses also aim to foster 4 core literacies, namely information awareness, computational thinking, digital learning and innovation, and information society responsibility. To be specific, we designed 27 courses in 6 modules as shown in this figure. In each course, we provide authentic learning content through real-world questions and practice for students to be actively engaged in the learning process, which accumulates in projected outcomes. For example, in the course Smart Bean for Waste Sorting in Module 5 Foundation and Realizations of AI, students will be able to design and program their own smart beans for waste sorting through speech recognition and image recognition, which reflects core literacies of information awareness, computational thinking, and information society responsibilities. Also, big ideas of perception, natural interaction, and societal impact. For each course, abundant multimedia ready-to-use courses are built for the whole teaching and learning process. Overall, we list all types of our resources here, including lessons, plans, slides, demos, games, etc. All instructional resources are free and open. Teachers and learners can easily access through a browser, and I will introduce them one by one. We use backward design to plan lessons and units. The teaching activities are structured based on project-based learning in context of students' daily life to engage students in problem solving. In rock, paper, scissors course, the driving question is how to design an automatic rock, paper, scissors game by means of computer vision. Then several subsections and the learning indicators are designed. For slides, we also developed the slides for each lesson, in which typical stages are introduction, new concepts instruction, hands-on practice, review, etc. The slides shown here are from rock, paper, scissors course. Students also are encouraged to do in-person survey to deeply understand the driving question. So in the course Information Coupon, we provide a questionnaire to guide students to be aware of personalized recommendations and information coupon, and find out methods to break through them. Also, we designed the warm-up game. Gamification is an attractive approach for students to stimulate motivation and get involvement to learning. In the course Smart Bean for Waste Sorting, we developed a warm-up game for students to get familiar with waste sorting rules. Students could get instant feedback when making each choice and accumulate scores when making the right choice. When it comes to challenging games or tasks, we record and provide demonstration videos to assist the students. In the course Exploring Tower of Hanoi, we developed the game via Python programming with self-painted animation displayed on the screen. The difficulty raises significantly when the number of plays increases, so we self-record the demonstration video, the optimal solution of 6-play Tower of Hanoi game, to challenge students and raise students' interests. When the course involving programming practice, it is significant for students to describe the algorithm logic clearly before hands-on programming. So we encourage students firstly describe algorithm in natural language and then move on to flowchart description. We also supplied different record tables to assist the students in various activities such as experiment, discussion, formulation derivations, etc. Quizzes are also provided to draw students' attention and assess students' understanding in and or after the course. We prepare detailed rubrics for students and teachers to evaluate project outcomes. In case students could not keep up with the class or work on hands-on projects in self-learning, instruction manuals are provided in which multi-level tasks and goals, step-by-step instructions and samples are specified. For the courses involving programming practice, we also construct programming resources such as demonstration codes and have them programming projects with preliminary environment setting up and data labeling. We provide both Jupyter Notebook codes and block-based programming codes. Although students in grade 1 to 9 are required to take AI courses, specialized AI teachers are still insufficient in China, as we mentioned before. So to prepare teachers' readiness in teaching AI in compulsory education, we aim to train at least 3,000 qualified AI teachers in 3 years with our teaching and learning resources. We have trained more than 900 teachers who are teaching or going to teach AI from 22 provinces in China. To solve the problems that teachers encounter in teaching AI, we designed our 2-day teacher training program, particularly as shown in the table. There are introduction of artificial intelligence and K-12 education, and also the 3 principles to design AI courses. For the third part, we select our exemplary courses mentioned in the last part to explain concepts and the technologies behind the course, and demonstrate the use of tools and the materials in the course. In the last part, we would also guide teachers to design their own AI lessons. After the teacher training program, we also conduct a survey to know more about our participating teachers. 192 teachers revealed that teaching AI is mainly challenged by lack of teaching experiences. And when asked about the satisfaction with our program, most teachers shows high overall satisfaction. In order to evaluate the effectiveness and improve the quality of the resources, the course of Smart Binful with the sorting was chosen to be implemented in primary schools. Taking one primary school in Beijing as an example, the participants gained significant learning progress in learning AI knowledge, and the students' computational thinking level also showed improved, especially in problem-solving dimension. In conclusion, our work makes great contribution to teachers' resources and training in the context of a new national curriculum for information science and technology in China. The AI knowledge structure organizes our teaching and learning resources systematically. So far, the resources of 14 online exemplary courses are developed that requires no software installation. To better facilitate teachers, a series of AI teacher training programs are provided. In the future, more courses will be developed, verified, and iterated to strengthen our AI knowledge structure. Thanks a lot.